How's everybody doing this morning? Good, yeah? Great, welcome. Thank you so much for being here for this presentation, and thank you, Argen, for the amazing opportunity to give me this forum to share some of the things that I've been very fortunate to have worked on and collaborated with some great people over the years. So, my focus in dentistry has always been digital. And, today what I'm going to do is not only show you pictures of things that are decent, but I'm going to show you actually how to do it. So, I'm from Toronto originally, Ottawa originally. Toronto, Canada is where I had my laboratory. I've been in dentistry since 2001. I started with Patterson Dental and eventually went to Henry Schein. And so my job at the time was to sell, integrate, and train CAD/CAM, CEREC, and E4D back in the day before they were 3D. So it was challenging, to say the least. And so I had sold a system to a fantastic prosthodontist, my mentor in dentistry. His name is Dr. Isaac Barzilay. He's a phenomenal surgical prosthodontist, and his office is in the middle part of Toronto. And so one of the cool things about being in that environment was that Dr. Barzilay and I he was a KOL for many companies, and so I was able to partake in all of that. And we did a lot of things with Biomet back in the day when ENCODE was the digital implant solution. So we worked all the time on trying to develop and push the boundaries of what the technology was actually designed to do at the time. And back then it wasn't designed to do very much other than to take pictures of single teeth. So I've been very fortunate to have gone through that path and then evolve on to where my career is today. Back then, it's great to have our Argen team here. Jeff and I connected when I had Gravity back in 2010, so it's been 13 years that I've been connected to the Argen family and have done a lot of work with them and helped them with some R&D on some of their bar projects. So, I'm going to be talking about a little bit of that today. So this is me. I'm from Canada. Take this information down. If there's anything today in this talk that you want me to expand on, help you with in your laboratories, with your doctors, whatever the case is, my philosophy in dentistry is to share as much of what I can as possible. Certainly nothing is perfect. It's dentistry. We all know that. But my goal is to be able to show you things that we've done, had successes with, issues that we've had in the process, what we've done to overcome them, and I'm here to share that with you, right? So collaboration is a big part of what we do. So we're located now in West Hollywood, California. I have an amazing team, some of which are here today, and we really work hard together to push the boundaries of using this technology in our space, and we work a lot with surgeons. And so I'm going to be showing you today, photogrammic scanning. That's the focus of what I'm going to be speaking about, and all of the data collection processes, items that are needed to successfully finish these cases for your surgeons and with their referring doctors. This is my family. Like I said, I immigrated to the US in 7 years. It's 7 years at the end of the month. So it's been like that. It's been gone. But this is my family. We have a 6-year-old little girl. Her name is Charlie. She's not so little anymore. Since COVID, we've been able to get back to Canada twice. We go in the winter. You may ask why. Well, because we live in Southern California. We get sunshine all the time, so it's nice to go up to play in the snow and get to skate and ski and do all the fun things you can do in the snow. And of course, we love the beach. So Tracy is my wife. She's from Northern California, and that's who I am. I love to play a lot of sports. I've always played a lot of sports, and it's something that I'm very fortunate that I get to do a lot of down here in the sunny weather. So, my disclaimer for this lecture, all of the things that we use and that I'm going to be speaking about what we use, I do it with our own accord. I don't get paid by any of these companies to use it. Nobody's provided me the technology. We own it all, we use it all, and we've gone through many iterations of trying to find combination of toys that work well together. What I'm going to show today are the combination of toys that we use that give us good results. So certainly they're not the only products on the market that work really well. There's lots. Explore them. But again, I'm here because I want to share what I do with you, and I want to show you, if you decide to do these sort of things, the combination of equipment and services that you can offer. So what are we going to talk about today? We're going to talk a little bit in the beginning about the terms and definitions of digital stuff. Historically, I've sort of glazed over this a little bit, and if everybody hasn't been exposed to digital, some of the terminology kind of goes like this. So I want to make sure you understand some of the terms that we're going to be talking about, because some of it is pretty new. We collaborate a lot. We're going to talk about collaboration, who we collaborate with, why we collaborate, and the results that we get from it. You know, we're in a business where there's a lot of great resources and a lot of great companies, Argen being one of them, and working together with them to, to use the tools that they've had and they've invested in and they've researched is really important. It'll help you get to that next level without necessarily having to invest in everything internally for yourself. Certainly people, human capital, and some of the manufacturing reps that you work with. The technology that we use in the lab to do the things that we do, and certainly you'll be familiar with most of them. We'll talk about how we use them, and I'll show you how we use them. I have a Trios here today. So when we do the live demonstration of how to do Photogrammic, we'll show you how that works. I have an iCam here today, so we'll be able to show you actually how we take the scans in the patient's mouths. So this, to me, is probably one of the most cutting-edge pieces of technology that we have in our space today. One of the things that Dr. Barsley and I back in Toronto was kind of our quest, was how can we do a full arch implant case 100% digital, right? No conventional workflow in it at all. And the missing piece of the puzzle, frankly, was the verification jig step. And so using Photogrammic, there's a few systems on the market. The iCam is the one that I choose to use, and I'll talk about why later. But it fills in that gap. It allows you to do that verification jig, final impression record the day of surgery. And it saves physically 2 appointments, sometimes 3 appointments for the referring doctor. And that's a big deal. That's a really big deal. So again, something that could set yourselves apart, and I'll talk about the business plan of that a little bit as well. Next, we'll get into creating a digital patient. So we're going to look at 2 different patients today. One patient is a fully edentulous patient, and the second patient is a patient that has teeth. So how do we approach these patients? How do we digitize them? How do we look at creating a proper smile for them, designing the pros first, and then moving that pros plan into the surgical treatment planning stage for a guided protocol, whether the surgeon decides to do fully guided or just use the pros as a guide to place the implants. And then after that, the stages that you go through to collect all the information. So I'm going to show you how to do that for both cases. Just out of curiosity, who in here is doing surgical planning for their market? Anybody doing surgical planning? Yeah. What softwares are you guys using?
We use the, I work with the owner. She does some of that stuff, but I do discuss the planning of what we're supposed to be doing.
Gotcha.
She goes through the system and designing it for the surgeon and the GP.
Yeah.
But I get the input of looking at the analogs or digitals, images, and going through the process.
Yeah, for sure.
Yeah,
and that, so he's just talking about his process that he uses. What software do you use?
I use 3Shape
for Implant Studio? Yeah. So, when you look at what this does for you and the relationship building capabilities that it has, like what you just said with your doctors, surgeons, and referrals, it's, yeah.
We do use the 3Shape, but there are other software that use the 3D and
the CT imaging and stuff. Yeah, exactly. Yeah, so we'll look at that. We'll talk about that today, and again, that goes into the side of collaboration and the benefits that working with these companies and their sales force and their professionals will have a significant effect on how you can present yourself in your market with a specialty knowledge. We'll talk about bars, right? We'll talk about after these implants are placed, how do we restore them, the different types of bars that we do today, which is different than the types of bars that we did 5 and 10 years ago, because we do mill material, so things are a little bit different, and the bar service that Argen has currently in the market. And then we'll go in and we'll do a live case. Now, I always recommend to people in these lectures, please ask questions, okay? I like to interact, I like to talk, I walk around a lot, I gotta make sure I'm not connected to anything here. So I have some toys, I'll walk them around, but if you have questions when I'm speaking, please put your hand up, ask, I encourage it. It's a lot of fun when we get to do things that way. All right, so let's get started. So collaboration, so So you guys do surgical planning for your surgeons. Has anybody else in here really dove in and tried to tap into the surgical market in your area, right? And why would you do that? Well, being in a specialty practice when I was in Toronto, working with Dr. Barzelay and ultimately the surgeons that he networked with, I quickly learned that working with the surgeon and getting access to the referral network is the best way to grow your business, right? Collaborate with them, share knowledge and expertise, be the teacher, right? Be the person that helps them digitize and work through their workflows, and then automatically you will become their best referral's best friend, right? You don't have to knock on doors anymore. It's a real thing, right? So collaborating and working together with your local surgeons, or implant reps is extremely valuable. But you have to bring something to the table, right? You have to bring some sort of education to the table. So I believe that it's our responsibility as lab owners and lab technicians and people in the laboratory space to know what is relevant and what technology is good to use, right? Because, you know, when the doctors that we work with have questions, who do they call, right? The first person they call is probably one of their specialty clinicians that they work with, whether it's a periodontist, oral surgeon, orthodontist, whatever, because those relationships are the tightest. The second people they call are us, right? They're not calling their Henry Schein rep, they're not calling their Patterson rep. Certainly could if they want information about materials, but you know, they're fixing teeth every day, so the communication, and I'm sure most of you have a great relationship and communicate very often with the people that you work with. So that collaboration, that link between specialty doctor and referring doctor is extremely tight, and if you can be part of it and bring them information that is useful to help them be more efficient in their practice, that is a lifetime relationship builder. And it's something that I believe in, it's something that we focus on with the people that we work with, and it's how we grow our business. You know, we're as good as our collective selves, right? So, you know, if I'm doing a program and we're training doctors and surgeons how to get more implant cases from their general practice to their surgical practice, that Straumann rep now becomes a salesperson for you. They're your support in your market. That Nobel rep becomes that person for you that can see these doctors in the market when you need help, right? So leveraging other people's resources is an extremely valuable part of being able to grow your laboratories. And I'm happy to talk about it endlessly, but if you want to have a side conversation on different strategies and stuff, certainly I'm open for that. You can call me at any time and we can discuss it. We work closely with the doctors, our restoring doctors. We give access to our designers to, you know, on a booked basis for the larger cases that we design, right? And the doctors that we work with that way absolutely love it. They feel like they're part of the team, right? And that's the culture that we try to cultivate at the space that we work in. All right, so let's talk a little bit about some of the terms of the things that get produced from these pieces of technology. So is everybody in here, is everybody in their laboratory digital? I'm not going to single people out and say who's not digital because I don't think that's fair. But certainly, if you're not digital yet, get digital. Argen can get you there, no problem. There's actually a program that if you want to get into 3Shape, there's a program that 3Shape is doing right now. Even if you are digital and you're expanding, they have a program on right now where you can add additional licenses at an extremely good value. I think it's 50% off for the license. And that's something that's offered through the 3Shape umbrella, and Argen are 3Shape resellers, so they can absolutely help you with that. So if you're expanding, do that. But when you're designing in software and a file is created, that file is called an STL, right? So that's the file format of the three-dimensional digital image that we use in our computers to design. That's pretty basic. Pretty much everybody knows what an STL is. PLY and OBJ are like fancy STLs. They're just colored versions of it. They have more mesh. And you know, when you're marginating and you're looking at images from different scanners, they now export PLY and OBJ as well, which you can import into the major design softwares to design your restorations. Certainly, it helps a lot when you're marking margins. DICOMs are the digital file format that is used, that gets produced from a CT scanner. So if you're doing surgical planning for your surgeons, and you want to come up with a plan for them and you're using whichever software you're using, We use Implant Studio and we use Co-Diagnostics. Those are the two softwares that we use, and I'll talk about why in a minute. But when you get the information from your doctor, you need an STL, PLY, or OBJ. That's your surface scan of the teeth, and you need a DICOM. The DICOM is a folder that has 300 slices of the images produced from a CT scan. And that's what you need to plan implant cases. So if you're doing that and you're going to be coordinating these cases with your surgeons, you have to be clear with them on what you need, because most of the time they aren't aware of what they need to export from their CT machines to give you to do a surgical plan. Now, people have been doing this for a long time, certainly, but you have to understand the link between what we need and the clinician's ability to understand and to be able to produce that, right? Because they live in this environment and they're doing implants all day, or they're scaling teeth all day, or whatever it is that they're doing. So again, falling back on us, the ownership to be able to educate them, to be able to help them understand, to be able to help them navigate how to export those files. It doesn't mean that you have to be a professional and understand with every CT scanner on the market how to create an open file format multi-slice file. You don't have to know that, but you'd be surprised it doesn't even register in their mind to call the people that sold them the scanner to figure out why. So, you know, your support can be so much as just saying, hey, call the people that you bought the scanner from and they'll teach you how to do it. Did you have a question, sir? Oh, sorry. DCM. So DCM is, a lot of people get confused with DICOM. DCM is the proprietary file format that gets created inside of 3Shape when a digital file is created. So if you're doing surgical planning, some offices might see that file and they'll send it to you, and it'll be a picture, or it'll be a 3D image of a digital impression. That's not what you need. So DCM is the 3Shape format of their internal, the file formatting for their 3D file. And photogrammetry. So photogrammetry was created in the 70s, late 60s, early 70s. The gentleman who owns iCam, his name is Horst. Great guy, brilliant man. He's from Switzerland. And the technology was actually created to accurately measure, it was for the military, and it was used to accurately measure huge items like boats and fighter planes and things like that to measure fuel consumption. Really peculiar that it ended up in dentistry. But it's the most accurate way for us to measure the position of implants. As of today, photogrammetry allows us to go to multi-unit only. The next stage and the evolution of it, and I know it's being worked on now, is to be able to mill bars and structures that would be able to go directly to fixture. It's something that's in the works. The two main systems on the market are iCam and PIC. So PIC is more of a flag style. They're bigger. iCam, it's a little bit smaller. They're sort of domino-shaped items, and I'll show you how all of this works in a bit. So that's some basic terminology of things that we're going to look at today. So different pieces of technology in this space. So when we look at creating a digital patient, there's a few different stages that we go through. The first stage is acquisition, is surface acquisition, the detail of the patient's teeth, like a physical impression. Right? I'm sure everybody in here accepts digital impressions. If you don't, certainly learn how to, and there's different portals and different ways to do it. And these are the systems that are on the market that we see the most scans come in from today. Certainly the lion's share, the bulk of what we get in the lab is coming from Trios and iTero. Probably a 50-50 split between those two for the most amount of work. Then we have PrimeScan, and then we have Medit. So they're all mobile. There's probably a laser thing on here. Yeah, there it is. This is the Medit on a cart. This is the Trios Move. This is the iTero HD, and this is the Ceric PrimeScan. So these are the units that the doctors have in their office. Certainly, there's opportunities for you to position these scanners in doctors' offices. If, you know, when I first started the lab in Toronto, my business model was buying scanners, giving them to doctors in exchange for a certain volume of business and train them how to do the dentistry. Again, a relationship builder. That's what the focus of the business for me has always been. But the economics of that don't really make a lot of sense for us as business owners, right? Because, you know, scanners, even if you get a sort of an open price range scanner now, they're $15,000 to $20,000 with the laptop computer and licenses that you need. Well, you can only buy so many of those until it bottoms out. It's better if the doctors own it. And what I found over the years, it's better if the doctors own it, because then they take responsibility for the work that comes with it. If it's yours and you put it in their office and you don't properly train them, and if you don't know how to train somebody on an intraoral scanner, get trained, right? Have a trainer come to the lab, have them bring the scanner, take the day out and learn how to do it, right? Because when you get scans in from the doctors that you work with and they're unreadable, everybody sees those every single day, it's real simple to coach them on how to make that better, right? And if you can do that, right, if you're that person that calls them up and says, hey doc, listen, you know, I just got in your digital impression and I can't really see the margin in your mind, you know, it's half the tooth, but you're gonna tell them it's a little area. But if you have a way to coach them to fix that, you know, that's love that keeps on going for that customer. So all of the scanners take good images. From my experience, Trios, iTero, and PrimeScan give us the best images in terms of cross-arch stability. And there is a specific scan path that you want to coach your doctors to follow, right? So I'm not going to go super deep into it right now, but let's say, for example, you know, somebody is scanning and they go in and they start doing all this rock and roll stuff, it's not going to build a solid model. You want to have them scan completely following a path and building the whole model first. And it's the same for every scanner because they collect data and they work pretty much all the same. So that's again, some little bits of information that you can share with the doctors if you're getting not great scans in from them, okay? And then this is the iCam, right? So again, photogrammic, measuring implants, being able to go direct to some sort of prototype. Certainly, if you want to skip the prototype stage, you could go to final. I've done hundreds of these cases with bars, right? And there's no leniency, there's no leeway in the accuracy of a bar fitting, and we've never had one not work, ever. And I could never say that about the conventional method of taking records for a full arch and save 2 appointments. So to me, I'm really excited about that. The next stage after we acquire the information, we have to do something with it. And so in our facility, these are the products that we use. So 3Shape, we use their design software to design, you know, single unit implant restorations, you know, 2-3 unit implant restorations, certainly smile design cases, crown and bridge, things like that. The more straightforward stuff. So 3Shape, I don't know if you know it or not, but they have 2 platforms. One is their dental systems. That's the lab design software that you have. The second software is Dental Desktop, which is the software that runs their Trios, right? But within the Dental Desktop software, it's the same platform that runs Implant Studio, Splint Designer, and those types of things. So if you're looking to get into doing that type of thing in the office, right? So let's say you have your 3Shape dental systems, and after this program, you're like, yeah, I think I want to get into doing implants. I want to leverage that surgical market in my neighborhood. Then you're going to talk to Steph or Jeff or one of their team members at the booth out there, and you're going to say, listen, I really want to get into doing digital implants. I need an Implant Studio license, in which they would sell to you. It's a separate dongle because they're 2 different softwares, but they would sell that to you and help you integrate it and train it. They have phenomenal support and training. There's a lot of videos. They have a great training team. So again, if you decide you want to do that, 3Shape has the 2 silos of software. So, okay. So again, Splint Designer, you know, the bane of the existence of when we first started doing splints, and one of my main guys, Edgar, is here, is designing splints digitally, man, because every dentist wants it different. And flat plane occlusion, cuspid rise, 30-degree ramp, flat tabletop, double, whatever. But you can design it all in the software, and it's super easy. And you know, there's a lot of really great splint materials on the market. We use Key Splint. There's a blue one and a white one, and it's real nice to work with, and patients absolutely love it. So again, if you want to get into that, that's the Dental Desktop platform. That's the second, not the one that you design in the lab, right? The conventional, let's call it legacy lab software for 3Shape. It's the Dental Desktop platform, so you have to buy a separate license for that. Okay? And these guys can help you. Larger cases, we use exocad. And we use exocad because it's designed to be able to do the larger cases better. You know, not a knock on 3Shape's ability at all, because it does work, but if the user clicks the clicker too much, it starts to slow down. I'm sure a lot of people in this room have experienced that. So we moved towards using exocad to design our full arch cases. Certainly it works exceptionally well when we're doing photogrammic because of the capabilities of manipulating the XML files, which gives us our implant positions when we're doing photogrammic. And also it's way faster if you do your pre-setups in there for the large cases, which I'll show you in a minute. And then once you get your implant coordinates, you just blend it together. It's way faster. So we use exocad for that. So those are our, let's call it pros design tools. Then we get into our implant planning. So we use Implant Studio, like I said, that's on the dental desktop platform. But we use Co-Diagnostics for our large stackable solutions. So if we're doing anything that's bone supported, whether it's just a bone supported guide with, for osteotomies, or it's a reduction guide with osteotomy, all of that sort of stuff, we use Co-Diagnostics. And we use that because it's a really great solution. It's probably one of the oldest ones on the market. Straumann has great support. But back to working with, leveraging relationships, they have a phenomenal sales team, right? And they have a lot of people doing it. They're the #1 implant company in the business. So they have the most amount of people, and on the implant side, the most amount of resources. And they have a solution, Smile in a Box, which they offer directly to doctors, but we can get it as well. So we can have an FDA-validated workflow for implant planning, right? Implant Studio is the same, where we can have their design software, use one of their printers, we have the P50, and their software and their material, and that closes the loop. Basically, you can design and produce to the same level as long as you learn the software properly that their Smile in a Box team does up in Montreal, right? So that's why we use it. It's a great solution. iMetric, that's the Swiss company that makes iCam. That's what we use for that. And then to put it all together, certainly once you design things, you have to produce it. So who in here is milling like composites, like hard composites, like Amberino, which is branded Crystal Ultra here, or things like that, right? So when you're looking at milling specific items, having the ability to go into your CAM software and tweak the feed speed and where it cuts and how often it cuts and things like that is really valuable, especially when you're using sort of unique materials. And so we use Millbox by Sim Systems for that solution, right? So all of these product categories, all different companies, but they all work together, right? It works really well. Right, so once we design something, then we have to produce something. Everybody in here is printing? Mostly, yeah? Variety of different printers. Is anybody printing crowns yet? Crowns, anybody? Yeah, starting to print crowns? Which materials are you using?
The ceramic crown from Sprint Ray.
Cool. Do you guys have a ceramic material on the go?
We're not printing anything with it. We don't like quite what it's producing yet, but
Yeah.
we're working on stuff.
Yeah, I've seen it. I've been watching it for a while as well. A colleague of mine consults with Sprint Ray. Sprint Ray is like 5 minutes from my house. And we went to the facility one day, and I get the concept behind it, but one of the challenges that I have with printing final restorations, probably the same thing that you've seen, is that it's still layers of something rather than a reductive process, which is what we get from milling. And so, just like when you print a model, sometimes you can see the striations, even if you keep your printers clean and calibrated and all of that, there are nuances with printing that could create porosities inside of the final restoration, which creates a weakness. So I like that material for, we use it on our digital dentures, right? So if we do a digital denture, a prototype, we'll print the base in Lucitone, we'll print that, or we'll mill PMMA, and we put them together, right? Because it's really nice. The nano ceramic printed for that type of application for us works really well. So we use Asigas in the lab. We have 2 of them. It was recommended by a colleague that has that manages a milling center. They use it for their FDA registered process. So to me, that's good enough. And then we have the P50 from Straumann, which is a great printer. So you guys have a printing solution that you offer as well, right? Yeah. So there we go. Here's all of the technology that you can work with Argen on. So the reason why I like Asiga and why we use them, and so when, one of the things, again, that we do a lot of with the doctors that we work with, is that if they want to get digital in their office, be the person that says, you know what, it's okay if you print yourself, no problem. I'll help you do it. In fact, I'll even help you get the machine, right? Because then you have them thinking that they have your trust, right? yeah, we might not print some things, but in the end, they're going to give you way more of the other stuff. Again, building that relationship. But the reason why I like Asigas and why we recommend to use Asigas with the doctors that we work with is because we get good results with it, and also because it's open. You can get the files, and there's all different types of materials that you can work with it. It doesn't keep you closed into choosing specific materials. And doctors like that, right? If they're printing temps or printing night guards or printing models or whatever it is that they want to print, there's a wide range of materials that you can use with it. And for milling, again, keeping it simple, we use, in the beginning, we were using Roland. And then we wanted to mill some things that needed a little bit more stability. So we moved into working with IMUS. And so we have the 150 solution. We have 2 of those, and we have a 350. And the reason why we have that, again, because if we want to do a clinical integration for a doctor that wants to mill in-house, I wanted to have a mill that we could put through the test, create CAM strategies for materials, again, something that you can offer to the people that you work with as well, which seems kind of like an oxymoron. Why would I sell a mill to a doctor that I do work with? Well, I guarantee you right now, you do that and they're going to realize real quick, I used to do in-office CAD/CAM, they realize real quick that it's not as easy as they think it is to be able to scan, design, and mill restorations. So if they're going to use it for temps, or they're going to use it for, you know, single crowns, that sort of thing, no problem. Help them with it. Help them design it. Help coordinate that for them. All right? Collaborate with them on that. Because when they do the larger cases, they're coming to you, for sure. Right? Because you have this special relationship with them now. So that's why we went down the path of using 150s, because when we do a bundle package and work with, let's say, iTero, to be able to put something together for an iTero doctor that wants to do more than just scan Invisalign, and they want to mill in office, well, that's the package that we go with, right? Because we get good results from it. It's not the only result. There's a lot of different options, but it's the ones that we've tested and we seem to find works really well. All right, so once we get all of this information, we've got to go back and we have to treatment plan the patient, all right? So the first patient that we're going to look at here, excuse me, this is the patient that I was introduced to. She's in Michigan, and so again, digital geography doesn't really matter. We work with surgeons and doctors all around the country. So this particular patient has extremely failing dentition, has had it forever, but came into some money and she wanted some new teeth. So I was introduced to her through a periodontist that I do a lot of work with out there, and the general dentist. And so this is the first patient that we're going to look at. So how do we go about collecting the information to treatment plan this case? Okay, one of the challenges that we always have whenever we're working on cases is, you know, not having the patient in front of us all the time. So when you look at digitizing a patient, it does that for you. And all of the softwares that you can use to do a 2-dimensional and 3-dimensional smile design, you can import the patient's face. Does anybody in here have a 3D patient face scanner, like a Face Ray or a Bellis or anything like that? Yeah, it's really cool, and it works. So we invested in Bellis a while ago. Unfortunately, the company didn't last, so I have a really expensive coat hanger sitting in my garage. But we have Rayface now, and so what that does is it takes the patient, they come to you, again, a service you can offer to the doctors that you work with, and it's not crazy expensive, so it's worth the investment, and you create a 3D scan of the patient's face. So the patient sits there, they smile, all the cameras take the pictures, and it gives you a 3D image that you can then import and align with your digital impressions and spin and turn around. If you don't invest in that, that's fine. Both softwares, both main design softwares, 3Shape and exocad, allow you to import 2-dimensional images of a patient's face. So even before you get to that stage, because there's a lot of work that goes into doing that, you can also do a 2-dimensional smile design. Right? So in Dental Desktop, the chairside software for 3Shape, and I'm sure there's others, I just don't know about them, and we don't use them, this is what we use. You can take a photograph of the patient, and you can literally in 5 minutes do a 2-dimensional smile design. This is something that at the Center for Aesthetic Dentistry at UCLA, they teach them how to do with Keynote, right? So it's a process that a lot of doctors do when they come up with a treatment plan and a proposal for their patients. They'll use Keynote or Photoshop or something like that. We now have the application directly in the dental software. What's cool about that? Well, the libraries that it offers you as a 2-dimensional smile design are the same libraries that are actually in the design software. So if you find something that's really good on that patient, you can export that information into the design once the patient signs on the dotted line for the treatment, and then you can move forward with the three-dimensional smile design, which is what this is. So why would you do that? Two-dimensional smile design will take 5 minutes. There's no resources needed. You don't even need to make a digital impression. It's easy, it's fast, it's simple. It gets the patient to the next level, looking at what the care can look like in their mouth, right? And so very powerful for a patient. This process requires a digital impression. It requires the designer to create an order in the software. It requires the designer to align the images. It requires the designer to virtually extract the teeth, do a digital wax up, which you need to charge for, right? So whatever you charge for a conventional wax up in your laboratory, $40 to $60, whatever your number is, you charge the same amount when you do it digitally because it takes the same amount of time, right? But it gives them more information. So that's what we charge. The same that we do is we don't do conventional wax ups, but if we did, I would actually probably charge more for a conventional wax up because it takes more time, and plus you have the added cost of the wax. But the reason I say that is because you can do a 2D and get that patient to the next level for care real fast, real simple, with very limited cost. We offer it as a service to the doctors that we work with because it's cool for them and it gets more patients to say yes. This is let's say a 12 tooth, this is 720 bucks. If you're gonna do a full arch like this, it's like an $800 lab fee for the wax up, right? So a lot of patients aren't willing to pay 800 bucks just to see if the teeth are gonna look good in their face or not, right? So it gives you an extra option to be able to do that. So this is the combining of the digital impression, trio scan with this patient in their mouth, and this is the actual digital wax up. So we go through and we virtually extract the teeth. And this is the start, the foundation of what we're going to use to come up with the treatment plan for the implants. So you always want to do that. If you're planning for implants, whether it's 1 tooth or 14 teeth, you always want to come up with a pros plan first, right? And even if you're working with a surgeon and the surgeon's like, I don't do guided surgery, you're like, cool, that's fine. I'm going to give you a digital denture, which is where we want the teeth to be. You're going to hollow it out, and they're going to use that as like a implant positioning guide for them. They'll freehand it, extract the teeth, do whatever, but you know that the implants will be in the right spot because you've already planned the teeth, right? So that's what this looks like. And the next stage to that is producing the immediate denture. So there's 2 reasons for this immediate denture. One is once they extract all the teeth, if they don't get primary stability, they need something for the patient to wear for the next 3 months. And having been doing this for a long time, it's the time where the general dentist thinks that they don't want to incur the cost of creating immediate dentures or the time to do it as well, is when that surgery happens and those implants don't integrate and they need it the most. So, I'm sure some people in this room have experienced that. So we always put as part of our package, part of our overall treatment plan for the patient, immediate dentures, right? Just in case. You need them anyways, because if you're doing photogrammic, it's part of the workflow, which is what you're going to see next. All right, so first stage of the planning is we take the CT scan, right? If the patient has teeth, it's a CT scan. If you're coaching your doctors, make sure that when they take the CT scan, they put a cotton roll between the patient's teeth, okay? Again, best practices. How do you coach the people you work with? Tell them the things that they need to do, help educate them, so then you can do what you need to do for them in the best way that you can. Why do you put a cotton roll between the teeth? Anybody know?
Separate occlusion.
Exactly, yeah. So when you're aligning surface scan, whether it's a model that you scan with your box scanner, or if it's a digital impression, you need anatomical markings to be able to align them. And if a patient is biting, you don't have the best ways to align, which is on the occlusal surface. You just have to use gingival points, and it could create misalignment, so that's correct. So in co-diagnostics, it's really cool because they actually have, they have AI built into it now, so it automatically segments the teeth and does the roots and creates patient coordinates. You can modify all of that, but that's what this looks like. So you have the surface scan and then you have your digital wax up, you combine them together and you come up with the implant plan, and that's what this looks like right here, okay?
How much planning is left for you with the AI on core diagnostics?
So it does the segmentation, it does the nerve marking, patient coordinate planes. You have to combine the surface scan with the CT scan. So you do that point, and after that you plan the implants. If there's bone reduction, you do the cut plane, and then it's just guide fabrication, which is kind of the power of their system, because it takes the cut planes and all of the information that you've put in and does all the alignment, right? So if I go back here, right? So it would come model with the roots segmented like that, and then it's up to me. So then I combine the surface scan with the CT scan, which is what you see here. Then I plan the implants, including the fixation pins. That's part of the implant planning process, okay? And then once that is done, you create a cut plane to the occlusal position of the implants, which is really cool because it forces you to make sure that your implants are aligned in a good spot, right? You know, in the very beginning, a bunch of years ago when we first started doing this, or ones that I've even seen that have come back from other designers, they forget to do that, right? So it gets it on a nice plane because you don't want a roller coaster for the restorative doctor. Once that is in, and then the guides, which is what this image is here, you go through the guide fabrication, and the stage one is the positioning guide. It's the how do I relate the osteotomy fixation holes to the teeth that is repeatable through the course of the case, which is what this is. So this sits on the teeth, just like a night guard, okay? With these arms, which tie into your fixation points. Surgeon drills, fixation pins go in. So then you have your bone, your holes, your osteotomies in the facial part of the bone, which is going to be your stabilizer for the guide. Okay, so that's step one. Step two, all the teeth come out, right? So the surgeon extracts all of the teeth. And then this is your foundation guide, right? Foundation guide / bone reduction guide, okay? So this is what the holes all line up with the original positioning, gets flapped, okay, fixated on the bone, and then this gives the surgeon a visual on what they need to plasty, right? And you know, the nice thing with this is that because you have the patient's face, you know where the transition line is. If you know where the transition line is, right, then you can make sure that you have enough length for your prosthetic, right? I hate reducing a lot of bone, right? Keep the bone. It's patient, it's there, it's not gonna grow back, right? So the least amount of bone that you have to reduce on these cases, it's always better for the patient. There's less inflammation, there's not nerves in the bone, but you know, perceived sensitivity for the patient. So you wanna be able to do that, and this is what it looks like, okay? From there, the surgeon reduces the bone, plasties the bone, and then the osteotomy guide goes on top and they place the implants.
Sorry to ask you, but on one of the images at the beginning, you just had a smart line. You didn't have the high smart line and anything like that. Where did you get that information for? You can push the...
Yeah, so he's asking in one of the first images, we just had the smile line, not the high smile line. So it's not in here. Whenever we do the initial treatment planning with the doctor, we have everything. Smile line, high smile line, retracted, we have it all, and we overlay that information together. And then we take measurements, right? So we know at this point that we're in the right spot. Yeah. Okay, so the implants go in. This is what they look like in the bone, obviously. All right, so then once your implants are placed, then comes the next step, which is, let's call it a chairside digital conversion 2023, right? So instead of taking the denture, you know, opening up the holes, putting in the temp cylinders, picking it up, luting it together, and doing all of that chairside, it's a different process now. So what you do is you have the surgeon place the multi-units, because the patient's flapped, the multi-units go in, and you're gonna see an actual live case. So this is all the digital stuff. The next case that I show is actually photos of an actual surgery. So if you don't like blood and guts, you might want to do that, but you'll see what it looks like clinically. So once the multi-units go in, yep.
You just state that he's still flat at this point?
Yep.
Okay.
Yeah, not at this point. This is post-suture, but
I know that is. But
yeah, clinically, yeah. So once the implants are in, the patient still is flapped, right? So you can see everything. The multi-units get put in, and they start torquing them down, right? If they start spinning, clearly, they have to make a decision whether what they're going to do with that implant. Usually they bury it. But you know, again, it's picking the cases that are going to work properly for this. If a patient has, and case selection is crucial when you do this stuff, if the patient has teeth, which this one did, if they have a ton of perio and a ton of recession and there's not a ton of bone, chances are you're not going to be able to load that case. And so these are conversations that you should recommend to the doctor that they have with the patient as a just-in-case factor, right? And having done a lot of these cases, probably half the amount of time that they plan on doing immediates and the patient has teeth, you can't load them, right? You got to bury them and they got to go home with a denture. So back to the clinical. So multi-units go in, everything is open. Then they take the, I'll just walk this around so everybody can see it. They take the ICAM markers, and I'll just walk around so everybody can see what they look like here, and they get screwed into the multi-units, okay? And the reason why you want to keep the patient flapped when you're doing this is because you can see and you know that they're seated, right? If you suture up the patient, everybody can see this, yeah? Yeah. If you suture the patient up and you try to put the multi-units on, there's blood, it's puffy, it's swollen, it's a mess, right? So do yourself a favor. Tissue doesn't matter when you're scanning this. This is just for the implant position. It's something key to know about photogrammic, right? We'll get the tissue record next, but it's going to be after it's sutured and after it's cleaned. So implants are in, multi-units go on, markers go on the multi-units. You can visually see that they're seated, so you know that it will give you the most accurate information that you can get, and you scan it.
There is no X-ray at that point. They're just visual.
Just visual, yeah. And when I do it, you'll see.
Is it just a hand torque?
Yeah, hand torque. Yeah, just hand torque is good.
Can you do implant level?
Nope, not yet. They're working on it. It's coming up.
Why can't you do that right now?
So they're.
Implant doesn't have multi-units on it.
So when we do those cases, what we do is we put the photogrammic markers on the other one, and when we do our tissue scan, we put a scan body on the implant that's going to fixture. So when we do our record, it will attach to the implant. But right now, so to be able to do that, you have to have the scan bodies, these ICAM bodies. You have to have this with a connection for every implant system that is out there. So let's say, Argen has their scan bodies, right? And so they have their restorative scan bodies for single unit implants, right? So there's Straumann, there's Nobel, there's Astra, there's BioHorizons, there's Zimmer, there's all of that. So for every connection, you have to have a domino with that connection, which is not the most crucial part. But the point is that if you're going to fabricate something to that, the person that fabricates it has to have their 510K and have to have it registered with the FDA because you're connecting something to an implant. Right? The reason why we can just do this and go straight to the multi-units is because that you don't need to do that. That's one of the parts of the
Multi-unit carries the 510K.
that. Exactly. Yeah. So this is how the systems are currently made. Understanding the demand to go to fixture is high, especially in the pros world, because not a lot of prosthodontists like that little baby multi-unit screw. But multi-units in the US is probably the lion's share of the market. In Canada, as an example, most people don't use multi-unit abutments. They go to fixture, right? So I think it's market driven as well. Okay. So this is what the scan looks like. This is the ICAM software. So again, going into the softwares that we use, once you get your records, we have to align all of the information, right? We have to be able to take the edentulous space, we have to take the teeth, we have to put it all together so we can actually make something that goes into the patient's mouth. So that's what this next step is. So this is the photogrammic scan, okay, your digital conversion, that's what that is. Then you take off the photogrammic markers and you put on the healing abutments. So depending on what implant system it is, right, this particular one looks like it's Nobel. Okay, so the multi-unit healing abutments go on the multi-units and the surgeon sutures up. It will give us our day of surgery tissue position. Okay, so why is that important? Well, it's what we use to be able to correlate the photogrammic scan to the teeth. So how does that work? This is the case right here. So we get this information, and then the next step is to take that immediate denture that you designed, that you know that the teeth are in the right position, and generally you have good stops because of the palate and the vestibule, and you do a wash impression of the healing abutments, okay? And you need to do that because the files of the healing abutments are attached to the CAD files of the ICAM references. right? So in the software, which Lewis will show you in a minute, and what this image is right here, it helps you align the teeth to the edentulous space, right? Because just like in regular implant design software, right? So you have a scan body, let's say it's on a single tooth, you have a scan body, and then you put your markers in 3Shape or exocad on that scan body, it swaps out the scan body and it puts in an analog. And then from there you build up your crown with either a tie base or a custom abutment. That's how the software works. Similarly with this, you have a scan body. It virtually removes the scan body by coordinate systems, and it replaces the scan body with the geometry of the healing cap, which is tied to an analog, right? So that's where the implants are. So when we take a record of where that is in the mouth, it allows us to correlate the intaglio of the denture to these markers in the software. So it's basically your wax rim and your tooth setup done all at the same time, right? You align it to the files. So then you have your teeth in relationships to the implants. That's how the software works. This is what it looks like, and this is what the intaglio looks like. So these are the healing abutments. At this point, we also make a digital impression, right? Because I want to have not only a wash impression, I want to have a physical impression of that arch as well. Right? The more data, it's going to help us align it, because one of the challenging things in all of the softwares, as you all know that of you who do it, is alignment, right? So if we have two surface scans, getting them perfectly aligned doesn't always happen all the time because tissue moves in different conditions, right? So we get as much information as possible to help us align it. So first we have the surgery, then we have the multi-units, then we have the ICAM reference and the healing abutments, the pickup, and then after that, it gets sent in, designed, and we mill the prototypes. So currently we're milling PMMA. The connection to the implant is direct with the PMMA. Is anybody doing zirconia directly to multi-units in here? Yeah? What's your success been? Yeah? So Nobel, I'm sure Nobel has a whole process for that, a zirconia that they're doing. They've gone through years of testing and they're very proud of it. Has a specific screw and all of that kind of stuff. And there certainly are a variety of different screws on the market today that you can screw directly to PMMA and zirconia that goes direct to the fixture. We do it with PMMA because there's no tie base or intermediary that goes there. Once we do that and we let the patient heal, usually we'll go to a bar with a superstructure on top, but that's more expensive. So I definitely see a place in the market for doing zirconia direct to the multi-unit. I just haven't personally done it yet because I haven't seen enough data on it yet. I know some labs in Florida, some colleagues work there, and they've been doing it for like 3 years, and they've done hundreds and hundreds and hundreds of them with a lot of success.
But you're right, there's not a lot of data.
Yeah, I was going to say, what's your input on this?
We're doing them. I mean, people send it to us.
Yeah.
We've got a lot of people saying, hey, we're doing it with your zirconia. And I'm like, awesome. Nobody knows what's going to happen.
Yeah. Are they using Rosen screw, or which one are they using?
Screw, Powerball.
Yeah.
Like even guys got, doing something similar to Nobel.
Yeah.
But there's a lot of questions on, depending on the shape of the screw, what type of stress are you creating internal to new zirconias, right?
Yeah.
If you want to go with the old school stuff that looks like chalk, it's got a different level of strength.
Yeah.
If you're using a aesthetic, anybody's new zirconia these days,
good chance it's
there's
gonna.
still research that probably needs to be done. So far, I've not heard any nightmares.
Yeah.
Doesn't mean it won't happen, though.
Yeah,
Right?
yeah, that's exactly why I haven't gone down the path. And there's a lot of factors that go into that. If you're milling yourself in-house and you're milling, let's call it a aesthetic zirconia, which is around 800 or so megapascal flexural strength, instead of the full strength stuff, which is like 1100 to 1300. First of all, it's significantly less strong, like Jeff just said. But then you have the factor of the screw, 1. 2, you have the factor on how the mill actually cut the seating surface inside the channel, right? So even if you have the best mill, sometimes that doesn't get milled exactly the way that it's supposed to be. So if you have a screw that is going in and there's a 3 millimeter area that didn't mill properly, well, that screw is going to bottom out there and you're going to have unbalanced forces, right? So if I were to do it, and I will eventually, probably. It'll certainly be with the strongest zirconia that you can find. And there's a group in Louisiana, I forget the name of the screw. This one that my friends in Florida are using, I can get the name after, I have it on my phone. And it's designed a little bit differently, more like the Nobel solution, but it does angled as well. And apparently it distributes the forces quite nicely. So, but again, like there's a lot of research that needs to be done in this. But for this patient, this is her prototype. So we'll mill it in PMMA, we'll layer pink composite. Pink composite, we use Annex gum for our pink composite. Certainly there's Gradia, there's a variety of different ones on the market that work really well. It's whatever works well in your hands. Nuances, you know, make sure that you put some sort of PMMA primer down, like Visiolink or something like that. So then you get good bond to your PMMA because resins don't bond to it naturally. And so the patient will wear this for a certain amount of time, sometimes 3 months to a year, depending on the patient's function and occlusion. That's up to the doctor. And then what happens next, right? So the patient's ready to restore. What would be the next stage, do you guys figure, to newly capture the tissue data?
I got a question to go back one step.
Sure.
What is the acceptance of your OSs about because you're not immediate loading that the data. No. So what is your timeline?
Yeah.
Normally it says 72-hour timeline is really how far you want to push it out.
Yep.
So is your workflow for you, are you bringing that or sending all that information back to the lab day of?
Yeah.
Let the conversion tech come and that information's there, you're starting the design process? Or do you do that the next day and come back the second day to load that prosthesis?
Thank you for reminding me to talk about that. I kind of went over that. So fantastic question. And so again, how do you do this, right? Principle of what we're trying to learn today is how do you do this, right? So the answer is the surgeon is okay, from my experience anyways, up to 2 days, maybe 2.5 days. So let's say a surgery is on Monday. So when we book these cases with surgeons, the first thing that we do is we tell them, hey, you want this thing, you know, fast, you have to have that surgery no later than 8 o'clock in the morning, right? And it's a single arch, right? So if they say, you know, the patient's coming in from wherever, I need it tomorrow. Well, if you need it tomorrow, you need to be done by noon. It's going to be a single arch, and you're going to see them tomorrow at the earliest 4 o'clock, right? Because the timing for the manufacturing of this looks like this. 8 o'clock in the morning, there's a surgery. If the patient has no teeth and they're fully edentulous, it's no problem because there's no extractions. Usually the guide will go in, they'll fixate it, they'll plasty the bone if plasty is needed, implants will go in. Usually by about 10:30 the surgery is done, okay? Multi-units go on, takes about a half an hour. Scan markers go on, takes about 30 seconds to scan it. And then you have all your records, you do your wash impression. So what we tell them is that we need to be out of your office by 2 o'clock, period. If we're not out by 2 o'clock, there's 0% chance to get it tomorrow. And the reason is this. So once we have all the data, right, we have the photogrammic scan, we have our pickup record of the teeth so we know how to combine everything, okay? Once we have all of that information, if you are using any of the modern day scanners, you can scan this stuff 360 in the patient's mouth or outside of the mouth. So we send it to the lab from the surgeon's office, right? Same thing with iCam, we can load it through our portal and they can get it fast. But once it gets to the lab, Lewis has to align everything. Aligning everything takes about an hour, right? He'll use iCam and then he'll go into exocad. But you have to remember, we already have the teeth designed, right? So we already have the vertical. We have the digital denture that was designed ahead of time that we use for the surgical plan. We have the lower and we have everything in occlusion. That's how we've built the case, right? So everything is set. So what the alignment stage is taking all of the data that we collected and combining it so that it's all aligned properly and cross-checking to make sure that it is aligned properly. Once it's aligned, then it goes to design. So it'll go to Sonia, who's in the back, who's one of our designers that does this designing in exocad for us, or Lewis, one of the two, and they'll merge the design of the digital denture with the digital files. That takes about an hour, right? An hour per arch, okay? So if we get everything back to the lab by 2, 2 to 3 is alignment, 3 to 4 is design, let's say 4:30, a little bit of messing around, let's say by 5 o'clock. The goal is to have it all done by 5, single arch. Once it's done at 5, we load the mill, mill it overnight. We cross our fingers that a burr doesn't break, right? Because like when we're milling PMMA, it doesn't take 5 minutes, right? It's 3-4 hours, right? If you want it done right, you use a C-clamp and you mill it right. That's what this is, right? So that takes 3 to 4 hours. So same day, no way. It's physically impossible. Would I print a temp, like an all-on-X printable material? I know they exist. We've tested a couple of them. Again, it depends on what the patient's expectations are, right? If the terminal implants are in a premolar and they want molar occlusion, there's no way. That thing's gonna bust 100%, right? And then you're just gonna have to redo it. So yeah, so we'll mill it when we use milled PMMA because it's stronger than printed material, and we're gonna do it overnight anyways. Now, fortunately, we have Jin who drives in from a little bit further south than where the lab is, and so he gets to the lab at 3 o'clock in the morning, and every day. It's not a when we do these cases thing, it's just that's when he likes to work. Leaves early, but that's what he does. But he starts and layers the pink composite. And what does it take you, 2 hours an arch? Hour an arch? 3 hours. Yeah. So, and we use rosin screws on these, right? So by the time that's done, we can get the case ready and out the door by noon. And we say 4 o'clock because there's always something that happens, right? So if they do double arch, then it's automatically 2 days. Single arch could be 1 day, we always say 2. Double arch, always 2. And that's the timeline on it.
So question, how other people are doing it same day? Like you have your preliminary data in,
Yep.
and you get your like denture or smile design. Basically what you do, you just merge your ICAM
Yep.
data,
Yep.
get your implant position,
Yep.
and punch the hole in.
They do it with a lot of stress.
Yeah.
Yeah, so, you know, I don't want to have that much stress in my life, and really at the end of the day, if you do it same day, so a lot of the people that are doing it same day have the infrastructure in their office, right? So my buddy who's in Florida,
In office.
they have it in office, yeah. So they have a person, digital conversion person that comes in the morning, they bring their iCam, right? This is what my friend does. His name's Taylor Torrey. I know him, you know him from, he was one of my colleagues back when my lab was, I sold to DSG. Anyways, he's in Florida, and so he goes around now with his iCam for his lab, and the surgeon does a surgery in the morning, they do it, they'll have the printer in their office, right? So he'll do it, he'll design it in their office on his exocad, right? And then they'll send it to the printer. And usually they say that they'll be done by 4 or 5 o'clock. He's never been out of there before 8 o'clock at night, ever. We had to talk about it yesterday. He's like, man, he goes, I love this idea, but it's killing me. He goes, how do you do it? I'm like, just tell him. You need an extra day. Patient doesn't want to be there anymore. Like, think about it. If you go in for a surgery, and you go in at 7 o'clock in the morning, prep for IV sedation, 8 o'clock is the surgery, and you're not leaving till 8 o'clock at night, no thank you. That's like, nobody wants to be there that long. The staff is cranky, the surgeon's cranky, the restorative doctor, if they even go, they don't, you know, it's one of those things. So again, it's coaching them from the experience that we have, coaching them that it doesn't make sense to do it that day, right? You can, but it's gonna be a lot of stress for everybody. And there's no difference whether you do or not.
So are you sitting at home wearing that prosthesis with the wash in there?
Yeah, they don't wanna wear it though.
What, I'm sorry?
They don't wanna wear it.
I'm just saying, if they wanted to, you could.
If they wanted to, yeah. And again, we give it to them. Like this, the restoring doctor will give it to them. I've yet to see anybody wear it. Yeah.
And as a backup, if you did do that, would you scan those prostheses and at least have a STL copy of that you could reprint at the lab in case things didn't line up?
So yeah, so we do that. So whether we do it, so if the patient, like this is, sorry, I drop it here. This is I think I have 2 of them here. These are, I'll pass one through each side. This is like the immediate denture design that we use for the pickup, right? And you'll see it when it comes back. We scan that while we're there. So we have it. So if we have to print it, we can.
It seems like it would be.
Yeah. And normally what we do is we have, yeah, yeah. So when we go for the surgery, we'll have 2 of them. We'll have one printed that the patient can wear home, and then we'll have another one printed that we use for pickup. And what we have found for materials when we do the one for pickup, which normally has like holes on the lingual side for the troughing of, we use a putty instead of an impression material now, it's more stable, right? You use like a polyvinyl putty, and you can just stick it in the holes so they get no palatal interference.
So my protocol is, I call that a reference denture.
Got it, yeah.
And it's just a printed white resin copy of
Yeah.
the actual.
Yeah, you'll see it when it goes, yeah. Here, let me pass you this. We originally did like denture material. I'll throw it. It's expensive. So what do we use? We use model material, right? So we use, what do we use? We use Whip Mix Very Model, great material. We print that, right? And it's harder, it's stronger, right? So there's no flex in the mouth. It doesn't crack, it doesn't break if you have to grind it, if the implants end up in a different spot. It gives you the opportunity to have something that's stable, right? But then you have a backup denture. We always make a backup denture for these cases. There's always a printed denture. Pink base, white teeth, just in case. And if not, it's the patient's backup in case something fails with the prosthesis. You just put it as part of the package. It's like $450. It's not the end of the world. All right, so that's the patient that has teeth. Does anybody? Yep, I was just going to ask, yeah.
Basically, you are printing a denture.
Uh-huh.
You're giving it to the patient just in case.
Yes.
So my question is, what's the advantage of using the ICAM system if the patient leaving from the office, no teeth, and you're already producing a denture? Why don't we just convert a denture that day? Patient leaves with teeth on, everyone's happy, no one stays until 8 o'clock, and no one comes back the next day.
Yeah, so relevant question for sure.
What's the advantage of going down this route versus just converting the denture that you already produced instead of that denture end up in the drawer?
Exactly. So the main reason is the time savings down the line of the process to treat the patient, right? So you have all of your final records.
For your final record, yes, I agree. Instead of like you're saving your verification jig, or even if you're doing a PMR where you're picking your provisional, using that as a provisional jig.
Yeah.
It's still, this is more accurate for the final data. But conversion, like the conversion part. Like
you already have it though, because again, back to managing the patient, right? So if the patient can go get the surgery, get a record, and go home, I guarantee 100% of patients, not necessarily, because some do want to leave with teeth. Yeah. I've yet to find a patient that was so pushed back that I don't want to do this. I'm not going to do it. If they know they're going to get it the next day, they're willing to go home from the experience that we have had anyways because of how we coach them with the information, that they're willing to go home and come back the next day to do it, right? They're tired, they want to be done with it. They know that they're going to get something that is going to be precision milled to fit the implant parts, which is what the prototypes are. Same thing as the final. Pardon?
What is the advantage for you or the doctor or the patient doing that?
Like time and accuracy, 100%. That's for me, right? Like, obviously we charge for the service, right? Because this isn't free. So we charge for a chairside conversion. We just call it ICAM, but we charge for the fee, so it's part of the business. But again, it's marketing, it's service, it's time for the patient, time for everybody involved, but ultimately the accuracy of what we get. Those are the big benefits. That's why we do it. Yeah. But yeah, you could put a denture in and cut holes in it and pick it up. Yeah, for sure you could.
And for the final, you can use that, which is you get your accuracy, you save your chair time, you save your appointment on the verification jig.
Yeah.
Final, I agree.
I look at temps the same way as I look at finals, though. I want the same. Because the prototype is my...
Using an appointment if you do that. So when the patient comes back later for delivery, that's an appointment you didn't need to do if you did a conversion. So... True.
But at the time of surgery, I've yet to see a patient say, nah, I want to sit in here for 5 more hours or 4 more hours or whatever to get this done.
Same amount of hours, different day.
Yeah, same amount of time, different day. It's not to knock conventional conversions. Listen, they've been working for years. This is just a new way to do it.
Just real quick, are you having the OS through that prototype in the next following day, or does that go back to the general dentist?
Which one?
The actual.
Oh yeah, the pros is going to the GP.
There's no real necessary reason for them to go back to OS, or do they prefer you to, or you set a general?
General dentist every time. Yeah, because the OMS wants to do more surgeries.
Absolutely.
Right? They want to keep on placing implants, extracting teeth, doing whatever that is that they do, and that's another benefit is that.
That is a huge advantage for them to be able to do 2 surgeries one day instead of one taking them all their day.
Exactly, and that's why they love them. Like we work with probably one of the biggest oral surgery practices in Los Angeles, and that's exactly it. We come in and do the records. They do 2 surgeries that day. In fact, we'll back-to-back them, right? Because if we're doing a conversion, that room is taken for 2 appointments, where they can place 10 implants instead of 5 implants. And that's how they make their money, right? So I guess that's a benefit of it as well, to answer your question. Was there a question over here?
Yeah. Question, you place the heel advantage on top of the might what I did about the wall.
Yep.
Is certain abutments are compatible to use in a lab, or can use any of them?
So that's it, yeah. So all of the, I shouldn't say all of the major implant systems have their healing cap CAD files loaded in iCam. And if they don't have it, when you buy one of these, when you buy an iCam, it comes with dominoes, and it also comes with metal healing caps that you can use if the surgeon doesn't, or if the implant system is like.
It has to do with the information is loaded on the iCam software.
Exactly. That's where the alignment is done.
Yeah.
Correct.
So the alignment done at this level.
Correct.
Before it goes to the extra.
Correct. Yeah. Yeah. All the alignment is done in there. Their alignment tool is awesome.
Second question. May I ask what you charge, what's fair to charge for this service for the conversion?
Yeah, sure. So we charge $1,000 for that service because the scanner is like 40 grand. But it gives us bandwidth. You know, we can always bring that price down. And some we do if somebody does a lot, or if we're doing 2 patients, we'll just charge $1,000 and be there for the day, right? Or if I have to go to Michigan to do it, I'll charge $1,000 and, you know, have them pay for my flight, right? So, but if we're doing something and they want a little bit better price, you can always go from $1,000 to $750. Or I don't know, what do you charge? What do you guys charge for a conventional conversion?
I'm the doctor.
Oh, okay.
I tell you what I pay.
Got it. Yeah.
The second question I have, this doesn't include the PMA, of course.
No, the PMMA is separate, yeah.
Separately, yeah.
Yeah. So we charge, like there's a package, but how we bill it is there's a fee for, because when you look at these cases, the surgeon wants to split. Some surgeons want to do a global fee. A lot of dentists don't want a global fee. They want to be able to bill it themselves because they manage it, right? So you're a dentist, right? Is that what you said? Yes. Where's your office? Okay, cool. Yeah, got it. So, you know, and you can talk to this if you want, but a lot of the surgeons will want to do the surgical fee, which is the stackable guide and all the planning and all that kind of stuff. And then all the restorative component gets billed to the doctor. And as lab owners, you can decide whatever is going to be best for that situation that you're in. We go both ways. So a lot of them will bill all the surgical stuff to the surgeon, and then the iCam fee and the PMMA will get billed as stage 1, right? So that's like $1,000 plus $1,300 plus the screws. That'll get billed for the day after surgery, and then the final gets billed after, depending on what material is used for that case, right? Because if you bill it all up front, a lot of doctors will give you pushback because it'd be like, well, why am I paying for the final now?
Hey Phil, we're 15 minutes out if you guys are doing it.
1.5?
Yeah.
Yes.
Okay, I better hustle. Okay.
You get the final, that's why. So you get the final.
Yeah, that too. Yeah, no, I understand. Yeah. Okay, we'll go through this edentulous data collection. It's very similar. This is just some clinical results, and then we'll do the iCam scan. All right, so this is a patient we recently did. This is her, again, face photography. So this was her existing dentition here. This is the digital wax up that Lewis did for her, and we shared it with her and the doctor. We couldn't really do much about the lowers. Her lip goes down, and these are her natural teeth. So we couldn't really extend it much further because she was clipping it, right? And so we prototyped it, and we made her a new digital denture, and we went through a couple of iterations to get the functioning right, but that's what we did. And so when we do digital dentures, we design them, we print them, and if the patient's edentulous, we get them to try it in. Make any tweaks, and then we take it back, and that's what we use as our record. So that's what we did for Margaret, is that we designed a new digital denture because her old one was no good. She wanted some changes. We made the changes, plus a few more, tried it in, she liked it. We used that to plan the implants. All right, so this is what the digital denture looked like, just on its own. So we print this, right, print it for try-in, and then we also do a final printed version, and this is the printed version that we use for our dual scan. Is everybody familiar with a dual scan? When you have a patient that has no teeth and you're going to be doing a surgical plan for that patient, you have to do a dual scan, which is essentially taking a denture, right? If the patient has one, make sure it's relined. It has to fit the tissue properly or your records will be off, okay? So you want to ideally make a new denture, which is what we did, and then print a version of that for try-in. Now, there's a little bit of funkiness going on over here, but that was corrected. So this is just a printed version of her denture, a monolithic version of it, and it's used as the dual scan appliance, right? So the denture scanned in the mouth, it's scanned outside of the mouth, and that gives us, with markers on it, and that gives us the data that we need to plan the implant. So that's how we proceeded with this case. The positioning guide, remember in the first one it sat on the teeth, right, to get our position in the mouth. This particular one is tissue supported, and we're using a bite registration here to make sure that it's in the right spot. So when you do a dual scan, again, if you're coaching your surgeons, make sure that they take a bite registration and put it in the patient's mouth while they scan the patient. It's how you verify the positioning of the surgical guide the day of surgery. That's what this image is. Once that is in, then the foundation guide, right? So blood and guts, sorry, if anybody's not into that. But this is the foundation guide, also the bone reduction guide, Placide, right? So surgeon, great surgeon, Dr. Morishita is a periodontist in Pasadena, great friend, phenomenal surgeon. And so this is the plasty of the bone. This is the osteotomy guide. This is the implants placed based on that denture design that we did. All right, so, you know, place the implants to the crest of the bone. Real nice, multi-units in, right? So whether the patient has teeth or doesn't have teeth, once the teeth are out and the bone is plastied, it's all the same process, okay? Once the multi-units are in, the iCams go in. Clean them, you don't want them covered in blood. A little tip, if you get into using this technology and you're in a situation and there's a lot of blood on them, make sure you wipe it off. It doesn't read it as well, so you want to make sure they're clear of blood. Little tip. All right, so scan the patient. Gesundheit. Take off the scan markers and put on the healing abutments. And we're going to do our wash pickup impression of the healing abutments. It's what correlates the teeth to the implants, right? That's what this is. This particular one right here. And 2 days later, she went to her restoring doctor. This is the design of the prototype in exocad. Okay, so she had bone deficiency on her upper right side. That's why that, but we corrected her occlusion, right? So we made sure the relationship between the upper and the lower teeth were good. Length was the way that we wanted it. And this is Margaret with the prototype delivered, right? She cried, it was nice. Yeah, she was really happy. She was going to the Derby the next day, so she was real happy to get her teeth in time. She's going to drink some mint juleps or whatever they're called, I don't know. Amazing lady, so nice. So now, whenever she's ready to restore, just like any patient in this situation, when we do this, we're able to create models with analogs in it, multi-unit analogs. If you know where the implant coordinates are, you can create models, which we will do. And then whenever this patient is ready to restore, or any of them, we'll have the general dentist remove the prosthesis, make a new wash impression on the intaglio, screw it in, and we'll get a record of the post-healing tissue that will translate into the design for the final, right? And they can take those records in their office and we'll help them with that. So Margaret was a good case. Final restorations, and again, part of this is what do you put on it when you're done, right? So we personally like putting bars underneath our full arch cases, whether we put whatever variety of materials are available to us today. PMMA, so our hybrids aren't processed anymore. They're milled with PMMA, and we'll cement them to the bar, anodized, and we'll wrap some pink composite around it to create that tissue contact, or we'll have metal directly to the tissue, highly polished, because tissue likes titanium. So this is a bar from Argen with this is Argen Z, I believe it is. Really nice material that they gave us for some prototyping, great material. This is kind of a see-through of the design of the bars. So again, we'll do the contact to the tissue with the metal, and then we'll have it come off the front of the bar. Pre-coloring, right? Adding the pink, creating a good foundation for your porcelains. And then these are, you know, two hybrids. The one on the right is PMMA, the one on the left is zirconia. So a little bit different, but it certainly gives you great results. All right, so those are the items that I wanted to talk about in the presentation. Does anybody have any questions about that before I do a scan? I know that we're light on time. Go ahead.
Using those dentures with the wash to maintain the vertical, how many chair side adjustments are you having to make that second day?
Not. So yeah, like when we inserted her prototype, I had intentionally, so she wanted, the terminal implants were just at the distal part of the premolars, but she wanted molars, so we had to take them out of occlusion. So we had proper contact all the way around, and I just had them, you know, take a little bit of the cusp, you know, flatten the cusp a little bit in the back. But Not a lot. And when you do, it's easy, right? It's, you know, it's PMMA, so it's an easy adjustment. And we always recommend that just like, you know, in a regular conversion, to have the patient go back to see the dentist, you know, 2 weeks after, a month after, to make sure that they balance the occlusion as things start to settle and they start to function. So very, very little. Like obviously nothing is perfect. There's a little bit of adjustment that's needed, but it's insignificant. Yeah. Okay, anybody else?
So what files are you aligning in the ICAM and the iMetrics software?
Yeah, so we're aligning the STL version of the pickup that we did. We're aligning the surface scan of the arch that we took with the healing abutments on it, okay, because we'll make an intraoral scan of that. And we're aligning so let's, you know what, you got it up there, right? So I'll get Lewis to swap it so you can actually see. So these are all the different images. You see up here, it's the whole data set, okay? Antagonist, pre-op, final references, upper, lower. Okay, and so those are all of the items that are aligned in there. So show them the ICAM scan. So this is the original design that we align with the denture, and then this is the surface scan of the tissue from the day of surgery, right? And the reason why I do this, even though the tissue around the implant sites is like, kind of like mashed potatoes, we get as much of the surrounding information, so then it properly aligns. More
You're even bringing in the design. Like.
Correct. Yeah, we take the original design that we had, which is what allows us to go faster, right? If you have to start the design from scratch, you're a couple hours for design instead of an hour.
Have you done much with like importing the STL, the CBCT, or?
We don't import that into here. That's all done in the implant planning software. Yeah.
So before you do the final, then you're going to go back and rescan the tissue at some point?
Correct. Yeah. After the patient heals, it, you know, let's say however long it takes, right? And most of, like we obviously the day after the tissue's pretty puffy, or 2 days after the tissue's pretty puffy. Some patients don't deflate, some patients deflate a little bit more. It depends on how much reduction there was. But what we're finding is that there's not a ton. This other thing that we do that a lot of surgeons like, and we'll charge extra for this, is that when the patient is healed, the prosthesis will come off and they'll retorque the multi-units. Right? They'll torque them to make sure that they're at 35. Because although they try to get them to 35 the day of surgery, if the implant isn't 100% integrated to 35, then they're not going to spin the implant out. They'll get as far as they can until they feel it, they'll leave it, and then whenever we do the final, we'll get the restoring doctor to go back in and torque it. And since we have all the data, we'll do upper-lower bite scan with an intraoral scanner, take off the prosthesis, scan the tissue so it all comes as one file, and then we'll re-photogrammically scan it and do the final. It's not like it's just like not everybody does it. Some surgeons demand it. So we charge for it.
The implant design software you use, does it export the STL file, or is it like the?
It does. Co-diagnostics, you can turn any image in the software. You can turn it into an STL file which is exportable with coordinates that all line up. That's the key, is the coordinate system, right? Yeah, as you know.
Your design can go out, because you said you use that one. What else do you use?
Implant Studio.
Implant Studio, it goes through Nobel first, and Nobel will send you the STL.
No, Implant Studio just goes through Implant Studio, and then you can import it into dental systems.
That's DTX implants.
DTX implants you're talking about.
So that one goes.
That goes to
but this
correct.
One just exports.
It just exports. Yeah, it's all wide open. Yeah.
Stackable guides and.
Absolutely. It's awesome. It's a great software. I've.
Where do you get it?
Straumann. Just go see Straumann out there.
The iMetrics software, is that available to people without an ICAM?
No. So the iMetrics software runs two of their hardwares. One is their ICAM, their intraoral camera. The second is their lab scanner, which a lot of milling centers have because it's a super accurate lab scanner. So people that are doing bars, labs will have that, and they'll scan their bar cases with that.
Sorry, I gave the touch back on
That's okay.
Designer software. Does it have the multi-unit too?
Yeah, everything. Everything for all systems.
With a multi-unit in place.
Yes. So you know your trajectory, and you can rotate your implant and give them the timing to stop it in the right spot.
And then I'm assuming it does export the model with the implant
Yes.
position.
All of that.
Including the multi-unit. So you can design, you can have basically your
If you want.
original printed or milled ready day of surgery.
You could if you're going to pick it up chairside, right? It's not like I wouldn't mill a prosthesis with the 2 fixture or 2 multi-unit connection, because if it doesn't go in the exact same spot, you're not going to have the seat.
They have to move it, like I get that
Yeah,
part.
but you can certainly, so the other part of the stackable solution is that you mill the prosthesis and it has big holes in it, and then there's support arms that sit onto the guide, right? So you actually pick it up chairside that day. So instead of doing a chairside conversion, like if you do a lot of chairside conversions, which it sounds like you do, co-diagnostics would work great for you, because you can design the pros ahead of time, know where the teeth are supposed to be, use the foundation guide to position it in the mouth, you put the cylinders on and you just use pickup or whatever material you use, and you're done. There's no converting the denture. You just pick up the fixed pros in the mouth.
Designing horseshoe at this point. And
Exactly.
other positions.
Yeah, you don't have to cut anything out, it's all there. And and there's a technique that we do, you design the intaglio of it to the virtualized position of the tissue post-bone reduction, so you're not filling in a lot in the gap. It works really well. Ben might be over there, or Summer, speak with them, they're good, yeah. You had a question, sir? You good? Perfect, all right. Live scan, you guys ready? Let's do it. All right, so. Where is it? Okay, so we're going to simulate the patient. So I'll just walk around quick. So I've already screwed in 3 of these iCam scan bodies into the multi-units. I have the 2 other ones here, which I am going to attach. Okay, everybody can see. Show and tell. I feel like my 6-year-old daughter. It's great. The screw unigrip is what they send you. Let me put on my glasses so I can see what I'm doing.
Does the timing of those dominoes matter?
Yes, it matters on how well it sees it. It doesn't matter for the accuracy. So his question was, does the timing of the dominoes matter? And the timing matters for the surfaces that the camera sees, not for how accurate it is. So once you screw it in, you want the edge of the domino facing out, so then 2 surfaces can be seen by the camera. It needs to see 2 surfaces is really what it's all about. Another thing to remember, I found this out the hard way, not knowing, when you set up your order, because I have a workflow that I go through when I do this sort of stuff, just like I'm sure for the people that do chairside conversions do as well. I always like to start with the upper. It's just easier, better access, etc. And so I'd set up a case, and the general dentist that was there decided that he started doing the lower first, and I had it set up as an upper, and the camera was scanning the dominoes, but it wasn't picking them up. I couldn't figure it out. It took me about 10 minutes to figure out what my issue was, and it was because I had the arches flipped. Yeah, now, you gotta watch this because it goes real quick. It's like magic. All right, so the first thing you do, camera's on, we set up the order in the software. Every time you do a scan, you just run it through this calibration plate, okay? So you just take the scanner, you can see on the screen, it's going to start to light up and it's going to start reading the calibration points on the scanner. Okay, so now it's done. So then clinically, the dominoes are in the patient's mouth. You have an optrogate. Does everybody know what an optrogate is? It's the thing that opens up your lips, or you can use retractors, whatever. And then you go in front of the patient holding the camera and you start scanning. Ideally, you want to get the dominoes in that little circle on the side. And as you capture the different size of the domino, it turns it red, and then it turns it green, and then you're done. So that's it. Final impression, verification, jig completed. That's it. It takes that little time. And again, you go through, you mark the images, you mark the teeth, right? So if you want to just mark them, Luis, here, I'll do it. So you just tell the software which teeth are which. Okay, so 18, 21, 22, 28, 30, accept, okay, save it, and then it gives Lewis everything that he needs to be able to go to the next stage and open up the file folder so that they can see what gets produced. Yeah, there we go. So it gives you the XML positions of all the implants. So if you're working in because this works in 3Shape and exocad. You can do both. So when we first started doing it, we were doing it in 3Shape. So you would set your order up in 3Shape with, let's say, the Argen IS multi-unit file in the implant positions. It's essential, it's crucially important to make sure that when you set your order up in your design software, that the exact same teeth are chosen as what you set it up in iCam with, right? But it has to be in the right tooth position. You can't say it's a 30 and it be really 28, because in the design software, it's going to try and connect the number 30 tooth to a 28, and you get that funky sort of screwed up looking connection part. You have to make sure they match, right? So the XML information gets translated in, and so when you set it up in 3Shape, you go, after you enter the order into your order setup using your library for your implant connection, you go into the advanced function, you right click, you go advanced, and it says import implant position. And you would go back into that file that Louis just had open, and there's an XML folder that gets imported, and that gives you all of the coordinates. So that's what drops the analogs into the design software for you to be able to design your bar or prosthesis or PMMA or whatever it is that you're designing. And this isn't just for full arch, right? So as long as there's 2 or more implants that are getting connected, I've done this a ton of times on patients that are, 3 implants in a 6-tooth segment, right? They love that. They don't have to make the impressions that way, right? So you would import this folder, and that's how it would work. Yeah, and it gives you the coordinates. So this is what it looks like in the iCam software, but it's similar in 3Shape. It would just have analogs on the other side of the model, right? And again, if this is something that you want to get into, then come see me or get my information. Switch back over to this one, please. I'll put it back up again. And I can certainly put you in contact with somebody in the US to look at Photogrammic and or the team here at Argen to help you with your 3Shape licenses. Does anybody have any questions about the things that we discussed today? Yep.
You said you started in 3Shape. What was the main thing that pushed you towards exocad?
It got too slow. Yeah. In a perfect world, I'd love to design them split file, like design a bar for the final, design a bar with the prosthesis on top. We haven't had good success with it yet, but yeah, it would get too bogged down, right? For those of you who use it to design full arch cases, 3Shape that is, if you make too many clicks, in the back end, the files just have all those clicks. It goes through every screen that it has to, re-import and save. We just found it moved a lot faster in exocad.
So it wasn't about the tools?
No, just time. Yeah, time and easeability of amalgamating existing files with new files. Yeah. Anybody else?
We also distribute exocad too.
Oh, you do? Oh, there it is. So if you're looking to do exocad and you don't have 3Shape, it's not on the thing. They're also exocad distributors, right? So you can speak to any of the Argen people at their booth in the main show floor, and they could help you with pretty much most of the things that we spoke about today, other than iCam. But that's to be continued. Hey guys, listen, I really appreciate your time today. Thank you for coming out. I hope your journey down this path is enjoyable. Enjoy the rest of your day, and I hope to see you out on the floor.